Question 1. The cost of various items sold at a shop are shown below. So we've got a table with the items and their cost. Part A. Find the total cost of buying a calculator, a file, and a pencil. So the total cost means we're adding them up. So we want a calculator, so that's £10.50. And then we're going to add a file, £3.59. And then a pencil, 55 pence. But these are in pounds, so I'm going to write that as pounds as well. So 0.55 pounds. And then I'm going to add them together. So 10.5, 3.59, 0.55. Check that you've got them correctly in your calculator. And then our total cost is 14.64. We're working in pounds, so that's £14.64. Part B. Nisreen bought 5 notebooks. She paid for them with a £20 note. How much change should she get? So she bought 5 notebooks. Let's see how much 5 notebooks costs. So notebooks are £2.49. So £2.49 multiplied by 5. £12.45. She pays for them with a £20 note. So I'm going to do 20, subtract the £12.45 to see how much change she gets. So that's 7.55. So it's £7.55. You'll get the marks whether you work in pounds or pence, guys. It's just my preference to work in pounds. Okay, part C. George bought 2 different items. He paid for them with a £5 note and received £1.90 in change. Which 2 items did he buy? You must show all your working. Okay, so first of all, he paid with a £5 note, received £1.90 change. So if I take £1.90 away from that £5, it'll tell me how much these 2 different items cost. So 5 subtract £1.90. Okay, so these 2 different items cost £3.10 in total. All right, so that's for 2 items, remember. So we're going to do some elimination to start off with. If the total cost of 2 items was £3.10, we can get rid of some things from this table. So one of them couldn't have been a calculator. That was a lot more than £3.10 just on its own. It also couldn't have been a file, okay? But it could have been a mixture of the other things, okay? So it could have been a notebook and a pen, or a notebook and a pencil, or those the same with a stapler. Okay, so we're going to try a couple of different options. Okay, so I'm going to see how much a notebook and a pen costs to start off with. So if it was a notebook plus a pen, that would be £2.49 plus 95 pence. So that's £2.49 plus 0.95. That's £3.44. So it's not a notebook and a pen. What if it was a notebook and a pencil? Because it can't be a notebook and a stapler because they would go over £3. Because 2 plus 2 is 4 for starters. And we've only got £3.10 to work with. So notebook and a pencil. So if we do notebook plus pencil. So that's £2.49 plus 0.55 for a pencil. So that's £3.04. So that's not £3.10. So one of the items was definitely not a notebook. So we're going to get rid of that because it doesn't work with any of the other 2 smaller items that are left. So one of the items must have been a stapler. So let's try the stapler and the pen to start off with. So £2.15 plus 0.95 for the pen. Oh, look at that. £3.10. So it must have been a stapler and a pen. (2A). Find the size of each of the angles marked A, B and C. So we're trying to find A, B and C. It tells us that the diagrams are not drawn to scale, so we can't measure anything directly from them. So we're going to need to use our angle facts guys, okay? So I'm going to start by working out A. So when I'm working out A, we have a straight line here. Angles on a straight line are 180 degrees, okay? So all of these three angles should add up to 180 degrees. This is a right angle, so that I know that that's 90. So I can take these two away from 180 and that'll tell me A. So A equals 180, subtract the 90 and the 47. So A is 43 degrees. So I'm going to pop 43 degrees there for A. So now I'm working with this diagram because I've got B and C. Again, I'm using my angle facts. So here we've got two vertically opposite angles. If they are vertically opposite, they are equal. So B is equal to 62. So I'm going to pop 62 there for B. The next thing I'm going to do is find C. So I'm going to work with this triangle here. And angles in a triangle add to 180 degrees. So if I subtract these two things from 180, I will get C. So C is 180, subtract 62, subtract 42. So C should be 76 degrees. Part B. The interior angles of a triangle are 65 degrees, and 50 degrees. Circle the correct mathematical name of this triangle. So here we need to know types of triangles, guys, and properties of triangles is useful as well. So we're going to go through these each one at a time to explain them. So equilateral, all three sides are the same and all three angles are the same. Those aren't all the same, so it's not an equilateral triangle. Right-angled. Right-angled triangle has one 90-degree angle. None of those angles are 90 degrees. Isosceles. Okay, isosceles triangles have two angles the same. 65 and 65 are the same. So isosceles is our correct answer. But let's talk about these. An obtuse angled triangle. So that's a triangle that has one obtuse angle in. All right. So an obtuse angle is greater than 90 but less than 180 degrees. And then a scalene triangle doesn't have any sides or angles the same. So it can't be scalene because we've got those two equal angles there. So the answer is isosceles. Part C. Measure the size of the reflex angle ABC shown below. Okay, so measure means we can use the diagram here, so we can measure directly from it. ABC forms angles here, but we're interested in the reflex angle on the outside. Now, this is quite clearly bigger than a straight line, because if this was a straight line, let me find my ruler, our line would continue, and we know that that part of the angle is 180 degrees, okay? I need to now find the rest of the angle, and then I can add it together. So what I'm going to do is I'm going to measure this bit of the angle here. So when I'm using my protractor, the centre of my protractor here goes on the point at which the angle is formed. My zero line goes flush to the line that I'm measuring from, and then I can measure round from zero. So I am putting the centre on, I'm lining up my zero line, and then I'm measuring around the outside until I get to this line here. Let me make sure I've got it exactly on the centre. So when I come around here, I'm going to read off that value, and that value is 120 degrees. So this is 120 degrees. So the total angle is 180 plus 120, which is 300 degrees. So we're going to put 300 degrees on our answer line. 3A. Part of a number line is shown below. Which number is the arrow pointing at? So we need to figure out what the increments of this number line are, so what these equal spaces are. So for whole numbers, we go from 7 to 8 and 8 to 9. So we know that this value is going to be between 8 and 9, so it's not a whole number. But we need to figure out what's happening between these two values. So from 8 to 9 on this number line, we have 1, 2, 3, 4 spaces, okay? So this one whole one from 8 to 9 is split into 4. So if you do 1 divided by 4, guys, which you can do on your calculator, tells you it's a quarter, and when I press the SD button, it tells me it's 0.25. So each one of these is 0.25. So this would be 8.25, 8.5, 8.75, and then 9. So our arrow is at 8.25. You could write it as 8 1/4 as well. You would get the marks for that, guys. Part B, circle 2 lengths below that are equal. So we have got a mix of millimetres, centimetres, metres and kilometres, okay? So I'm going to start by using just one of the values, okay? So this 1,740 millimetres, okay? And I'm going to convert it to centimetres and metres and kilometres. And then if I get any that match within this, I've got a matching pair. And then if that doesn't work, I'll move on to the next number. We're going to do it systematically. Okay, so to convert from millimetres to centimetres, 10 millimetres is 1 centimetre. So if I divide by 10, 1,740 divided by 10, this is 174 centimetres, okay? So 1,740 millimetres, we've got 1,740 centimetres, they do not match. We have 174 centimetres, so that was quite handy. So we're going to pick these 2 lengths because they are equal. Question 4a, write the following statement using the correct mathematical symbol. So the statement says that 0.24 is less than 0.3. So 0.24 is less than. So this is our less than symbol, and 0.3. So that's our mathematical statement. Part B, give calculations to show that the following statement is correct. So 18% of 160 is the same as 2/3 of 43.2. So I need to show some calculations that this is correct. So I'm going to carry out this calculation, and then I'm going to carry out this calculation and show that those answers that I get are the same, which means the statement is correct. Okay, so to find 18% of 160, this is a calculator paper, guys, so I'm going to show you a calculator method, okay? So if I want 18% of 160, I want 18 as a decimal multiplier, so 18 divided by 100 is 0.18. So if I do 0.18 times 160, that gives me 28.8. Now I'm going to work out 2/3 of 43.2. So 2/3 of 43.2. So on my calculator, I'm going to do 2/3 multiplied by 43.2. So 2/3 is a fraction. Arrow off your fraction, guys. I don't know if you can see that clearly, actually. That's a bit better. And then we're going to multiply by 43.2, which gives us an answer of 28.8. We have shown that this statement is correct using calculations. Question 5. Roman has 9 cards shown below. 1, 2, 3, 4, 5, 6, 7, 8, 9. You must only use the numbers on these cards, so we can only work with these numbers, and we've got to show all our working for this question, guys. So part A, 1, calculate the sum of the 2 prime numbers. So we need to identify the prime numbers in this set of cards here. So remember, prime numbers only have 2 factors, 1 and themselves, so they don't appear in any other times tables apart from their own times tables and the 1 times tables. So to start off with, there's only one even prime number, which is 2. 2 doesn't appear in our list, so actually any other even numbers can't be prime. So we're going to ignore even numbers and we're going to look at the odd numbers. Well, 9 is in the 3 times tables, so that can't be prime because it's in the 1s, the 9s and the 3 times tables. 13 is our first prime number. And then 14 is even, so it can't be prime. There's only one even prime number. 15 is in the 5 times tables as well as the 1 and the 5s. It's also in the 3s, so that's not prime. 17, that's another prime number. We're doing the sum, so we're adding. 24 is even, so that's not included. 27 quick spots in the 3 times tables, so that's not odd. 32 and 36 are even, so they are not prime numbers. So we're going to add these two together. So 13 plus 17, didn't write it in my calculator correctly, is 30. Okay, part 2, calculate the product of the 2 square numbers. Okay, so whereas sum means add, product means multiply. So we want to multiply the 2 square numbers together. So remember, a square number is the answer you get when you multiply a number by itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So that's our first square number. We're doing the product. 4 times 4 is 16. 5 times 5 is 25. Neither of those are in here. 6 times 6 is 36. So we're doing 9 times 36. So that's 324. Part 3, find the number. So just one number which is a factor of 72 and a multiple of 8. Okay, so factors of 72, we're going to start with those first. So factor pairs, 1 times 72, 2 times 36. If you're not sure, guys, 72 divided by 3, 3 and 24. 72 divided by 4, 4 and 18. 72 divided by 5 doesn't work. 72 divided by 6, 6 and 12. 72 divided by 7 doesn't work. 72 divided by 8. So you've got 8 and 9. 72 divided by 10, nope. 72 divided by 11, nope. And then we're back to 72 divided by 12, and we already have that. So this is all of our factors of 72. We want multiples of 8. So we want them to be in the 8 times tables. So no, 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 no. 8 is in the 8 times tables. 9 isn't, 12 isn't, 18 isn't, 24 is in the 8 times tables. Let's check these two. 36 divided by 8. Nope. 72 divided by 8. That's in the 8 times tables. Do we have any of these 3 numbers in this list of cards? Well, we don't have the number 8. 24. We have the number 24. So that is the number that is both a factor of 72 and a multiple of 8. Part B. Roman picks one of his 9 cards at random. So he picks one card at random. He says, I have a 2 out of 9 chance of picking a card with a cube number on it. Is Roman's statement correct? Yes or no? Show how you decide. Okay, so we're going to decide what his probability of picking a card with a cube number on is before we tick a box, guys. Okay, so cube numbers. So a square number, you times it by itself twice. So 1 times 1 is 1, 2 times 2 is 4. A cube number, you times it by itself 3 times. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3. 27. 27's in this list. And then 4 times 4 times 4, 64. We've gone too high. So actually there's only one cube number in this list. So there's a 1 out of 9 chance of picking a cube number. So he's incorrect because he said there was a 2 out of 9 chance. Oscar is making a model of his house. So there's a diagram of the house. It's not drawn to scale, so we can't measure anything directly from it. He decides to use a scale of 1 centimetre represents 1/4 of a metre to make his model. Part A. His model is 30 centimetres tall. How tall is the actual house? Okay. So 1 centimetre represents 1/4 of a metre. Okay. So 1 metre is 100 centimetres. So 1/4 of a metre would be, in centimetres, 100 divided by 4. So 25 centimetres. So 1 centimetre on the diagram is 25 centimetres in real life. So we're going to convert his model height to his real life height. So I'm going to use a proportion table. If you've seen my previous videos, you know that I quite enjoy these. So centimetres, oh well, I'm going to change that actually. I'm going to go model and then real. So the model is 30 centimetres tall. We don't know what the real one is, but we know that 1 centimetre on the model is equal to 25 centimetres in real life. Okay, so we're going to scale up from here. So 1 times 30 gives me 30. So if I times by 30 on this side, so 25 times 30, so it's 750 centimetres in real life. So his actual house is 750 centimetres tall. However, I'm going to change that, guys, to metres. You don't have to, but I don't think centimetres is a reasonable thing to talk about house height in. So I'm going to say that that's 7.5 metres tall. You will get marks for either of those answers, guys. Part B. The front window of Oscar's house is 2 metres wide. How wide should the front window be on his model house? Give your answer in centimetres. Okay, so another little proportion table to organise my thinking. So model, real. So our scale is 1 to 25 from earlier. The front window of his house is 2 metres wide. So 2 metres is 200 centimetres. So in real life, we've got 200 centimetres. We want to find out how many centimetres on the model. So we're going to scale up from 25. So 200 divided by 25 is 8. So I need to multiply by 8. So when I multiply by 8 on the other side, that tells me that the window on his model should be 8 centimetres. I don't need to convert it because it's told me that it wants my answer in centimetres. Question 7. The following sequence of patterns is made using lines and circles. So pattern 1, pattern 2, pattern 3, with a mix of lines and circles. And underneath it tells us how many lines and circles for each pattern. Part A, how many lines and circles will there be in pattern 5? So we have pattern 1, pattern 2, pattern 3. We're interested in pattern 5 and we're interested in lines and circles. So I'm going to deal with the lines first. So in pattern 1 there are 6 lines. In pattern 2 there are 11 lines. In pattern 3 there are 16 lines. So I'm going to see what this sequence, because it tells us it's a sequence, is going up in. So I'm going to do 11 take away 6. So from 6 to 11 we add 5. Double check, 16 take away 11. Yeah, we've added 5 here. So I'm going to keep adding 5 till I get to the 5th pattern. So this would be the 4th, this would be the 5th. So 16 plus 5 is 21. 21 plus 5 is 26. So there will be 26 lines. I'm going to do the same with the circles now, guys. So in pattern 1 it's 5, 8, and then 11. So let's see what it's going up in. So 8 take away 5, add 3, 11 take away 8. Yep, that's 3. So we're going to add 3 till we get to that 5th pattern. So 4 and 5. So 11 plus 3. And then 14 plus 3 is 17. So there are 17 circles. Part B. Is it possible for a pattern in this sequence to have 36 lines and 24 circles? Yes or no, show how you decide. Okay, so we've got a couple of different ways we could do this, but I'm going to do it by comparing the sequences. So here we have lines, circles. So I'm going to write this sequence. So 6, 11, 16, 21, 26, and then the circles underneath. So 5, 8, 11, 14 and 17. Okay, so is it possible to have 36 lines and 24 circles? No, it's not, and I'm going to tell you why, guys. This is an even number of lines, so if we have a look at everywhere we have an even number of lines, let's look at what the corresponding number of circles is. Well, actually, the corresponding number of circles are odd values. So if there's an even number of lines, we have an odd number of circles. If there's an odd number of lines, we have an even number of circles. So I'm going to say, no, it's not possible because 36 and 24 are even. And then I'm going to say a little bit when the lines are even, the circles are odd. Question 8a. A head teacher wants to put a new carpet in one of his classrooms. He uses carpet that costs £12.48 per metre squared. The diagram below shows the dimensions of the classroom. So it's a rectangular classroom and it's 8.5 metres by 5.5 metres. The diagram's not drawn to scale, so we can't measure anything directly from it. How much will it cost to buy the exact amount of carpet needed to cover the classroom? So whenever we get any questions that are dealing with carpet, flooring, grass for a garden, soil, that kind of thing, we're dealing with area, because we're dealing with filling in the space inside the shape. So we need to first of all find out the area of the classroom. Okay, so the area of the classroom, it's a rectangle, so we do length times width. So 8.5 multiplied by 5.5. So that's 46.75 metres squared. Now each one of those metres squared costs £12.48, because it's £12.48 per metre squared of carpet. So we're going to multiply this by £12.48 to find our total cost. So 583.44. So it costs £583.44 to buy the carpet that covers the classroom. Part B. The head teacher needs to buy vinyl flooring for a different classroom with an area of 67.2 metres squared. It's sold in rolls that each cover an area of 10.5 metres squared. What is the minimum number of rolls of flooring he needs to buy? Okay, so the area is 67.2 metres squared. Each roll covers 10.5 metres squared. So we're going to see how many 10.5 metres squared we have. So we're going to divide 67.2 divided by 10.5. So that's 6.4. So we're going to need 6.4 rolls. We can't buy 0.4 of a roll, guys. So we're going to have to buy 7 rolls to make sure we have enough. Question 9. Below is a recipe to make a batch of 12 flapjacks. So this is the recipe and how much of each ingredient we need to make 12. Part A. Complete the table to show how much of each ingredient would be needed to make 72 flapjacks. Okay, so we've got a recipe for 12. We want to be able to make 72 flapjacks. So I need to start off by dividing 72 by 12, which is 6. So I need 6 lots of this recipe to make this recipe. So I'm going to multiply everything in here by 6. So for porridge, we're going to do 240 multiplied by 6. For butter, 125 multiplied by 6. Notice that I'm writing these down as well as writing the answers down, because if I press something wrong on my calculator, which I do quite a lot, I'm showing them I'm trying to do the right sum. Even if I get the wrong answer, there's marks there for me, guys. Showing you're working out is important on a calculator paper. So sugar, so we're going to do 100 multiplied by 6. And then golden syrup, 2 tablespoons. So 2 multiplied by 6. We need 12 tablespoons. Okay. Part B. Natalie has 1.75 kilograms of butter and plenty of the other ingredients. What is the greatest number of batches of 12 flapjacks Natalie can make? Okay, so how much butter we have is the thing that determines how many batches we can make, because everything else we've got lots of. So we're working with butter, guys. So for 12 flapjacks, so up here, we need 125 grams of butter for 12 flapjacks, okay? So we will need 125 grams of butter to make 12 flapjacks. We have 1.75 kilograms, so let's change that. 1.75 kilograms is equal to, times by 1,000, guys. Oh, times by 100. 1,750 grams. So we have 1,750 grams of butter. Let's see how many lots of 125 we have. I couldn't do the division before because we had different units. So that's 14. So we can make 14 batches of 12 flapjacks. Part C. This note is written underneath the original recipe. To make 15 flapjacks, use 25% more of each ingredient. Show that this statement is correct. Okay, so the original recipe makes 12 flapjacks. Okay, so the original is 12 flapjacks. If we want to make 15, we're wanting to make 3 more flapjacks than the original recipe makes. So we need to find out what percentage of 12 of that batch 3 is. So let's do 3 over 12 and multiply it by 100. I'm going to do that all in my calculator, guys, because a fraction multiplied by 100 gives me a percentage. So 3 flapjacks is 25% of the 12. So if we use 25% more of each ingredient, then it's correct. Question 10a. Simplify 5f, add 6g, add 3f, minus 9g. So this is collecting like terms, guys. So what I need to do is get a highlighter and I need to highlight my terms that are like terms. So to be a like term, they have exactly the same letter and exactly the same power. So 5f and the plus 3f are like terms. I've highlighted the add that's in front of the 3f because that's important, guys. We also then have plus 6g, the sign in front of it stays with it, guys. And then minus 9g, the sign in front of it stays with it. So we have, in terms of the f terms, 5f add 3f, which is positive 8f. And then when we're dealing with the g terms, we have positive 6g. Take away that sign in front, guys. Take away 9g. 6 take away 9. Do that in your calculator if you're not sure. Is minus 3g. Now I'm going to write this as an expression. 8f subtract 3g. Part B. Expand 5 multiplied by m subtract 3. So we're expanding brackets. Many different ways you can do this, guys. What we have to do is make sure that everything on the outside gets multiplied by everything on the inside. So the 5 has to get multiplied by m and by negative 3. So 5 multiplied by m is 5m. 5 multiplied by negative 3. If you don't know your negatives very well, guys, stick it in your calculator. That's minus 15. And that expression there is our solution. Part C. Find the value of 6x add 3y when x equals 5.2 and y equals 0.4. So this is a substitution question. We've got an expression that has x and y in there, but they tell us the values of x and y. So we're going to substitute those values in. So we have 6x, but instead of x, we're going to write 5.2 plus 3y, but instead of the y, we're going to write 0.4. And I'm going to pop that in my calculator. So 6, 5.2 plus 3, 0.4. I've put it in exactly as I've written it on my paper, guys. And that tells me it's 32.7. Part D. Solve. E divided by 2 subtract 4 is equal to 6. So E over 2 subtract 4 is equal to 6. So the first thing I'm going to do, guys, is I'm going to eliminate that fraction. I'm aiming to solve for E, so I want to isolate E. I don't want it to be in a fraction. So this is E divided by 2. The opposite of divided by 2 would be to multiply by 2. So when I multiply the left-hand side by 2, that cancels out my fraction. It leaves E. But this negative 4 needs to be multiplied by 2 as well. A lot of people forget this. So 2 times negative 4. Again, use your calculator if you're not comfortable with negatives. So I've dealt with the left-hand side, but as always, I need to do the same to the right-hand side to balance the equation. So I'm doing 6 times 2, which is 12. Now I have a one-step equation. I'm aiming to solve for E, remember, so I'm aiming to isolate E. So the next thing I'm going to eliminate is the subtract 8. So the inverse of subtracting 8 is to add 8. So when I add 8 to the left-hand side, that cancels the 8 out. And then when I add 8 to the right-hand side to balance the equation, that tells me that E is equal to 20. Part E, the rectangle below has a length y and a width x. So length y, width x, not drawn to scale, so we can't measure anything directly from it. 3 rectangles congruent to the one above are arranged without overlapping to create the large rectangle below. Again, not drawn to scale. So 3 rectangles congruent to this one, so exactly the same as this, have been put together with no overlaps to make this big rectangle. Find an expression for the perimeter of this large rectangle in terms of x and simplify your answer. Okay, so I'm going to start by labelling what I know from here onto this diagram. So any lengths we're going to label as y, guys. Okay, so this is y. Let me get my ruler to make it clear. Oh, wobbly line did not mean that. This is y. And this is y. Okay, so I've labelled any lengths. I've only labelled the ones that are on the outside because when I'm working with perimeter, I'm working with the outside of the shape. We might need to use the inside to help us, but for now I'm just labelling the outside. Okay, and then I know that these widths are equal to x. So this is x, this is x, and then down here, this is x, and this is also x. Okay, so we have all of the sides of the outside of this rectangle labelled with an algebraic value. However, it wants an expression for the perimeter in terms of x. So when we add these all together, we don't want any y's in there, guys. So we need to look at our diagram a little bit closely. So we know with a rectangle we have 2 pairs of parallel sides. This side and this side are parallel and are equal. This side and this side are parallel and are equal. So that tells us that y is equal to 2x. So I'm going to pop that here. Y is equal to 2x. So now instead of having y, I'm going to write 2x. So here we've got a y, here we've got a y, and here we've got a y. I'm going to change those. So that's 2x, 2x, and 2x. Now, when we look at this, I have all of the dimensions around the outside of this triangle in terms of x, which is what it's asking for. So I'm going to add those all up now to get my expression for the perimeter. So we are working with x, and I'm going to tick it so I know I've used that one, plus 2x, plus x, plus 2x, plus x, plus x, plus 2x. And by ticking it, I know that I've included that side and I'm not using any more than once or whatever. Okay, so let's add these together. We have 1x. And I'm going to use my calculator to keep track here. So we've got 1x plus 2x plus 1x plus 2x plus 1x plus 1x plus 2x. So we have 10x in total. So the perimeter is equal to 10x as an expression in terms of x. Question 11. Fahima has a sack that contains a number of identical balls of different colours. The table below shows the probability of randomly choosing a ball that is red, green, yellow or blue. So this is the table here. Part A. Fahima claims there are other balls that are not red, green, yellow or blue in the sack. Explain why she is correct. Okay, so if there are other balls that aren't red, green, yellow or blue, then we would have another value that we could include in this table. Now what we need to remember is probabilities must sum to 1. Okay, probabilities have to add to 1. So let's see what these add up to. So 0.32 plus 0.46 plus 0.1 plus 0.12. Remember, I'm writing down everything that I'm doing in my calculator, so if I enter it wrong into my calculator, they know I was trying to do the right thing. Right, they all add up to 1. So she's incorrect. There can't be any other colours in there because probabilities sum to 1. Part B. A ball is chosen at random from the sack. Calculate the probability that the ball is green or yellow. Okay, so we're dealing with a probability that the ball is green or yellow, which is 0.1. So with the or means we are adding, guys. So the probability is 0.56. Part C. Fahima uses the sack of balls for a game at her school fair. In the game, each person pays 50 pence to choose a ball at random from the sack. The ball is then returned. The player wins a prize worth £2.95 if a blue ball is chosen. 150 people each played the game once. How much profit would you expect Fahima to make? You must show all your working. Okay, so we're working with the blue ball here. So I'm going to, from the table here, the probability of a blue ball is 0.12. So the probability of winning is 0.12. Because to win, they need to pick the blue ball. 150 people each played the game. Okay, so they played it once. So each person plays 50p. So I'm going to do 150 times 50p. So that's 7,500 pence, which if I divide that by 100 is £75. So she makes £75 from people paying to play. But we need to figure out how much she would pay out. So we need to figure out an estimate for how many people would win. So how many people are going to pick a ball that's coloured blue out of this sack. So the probability is 0.12. 150 people play. So 150 multiplied by 0.12 is equal to 18. So we expect 18 people to win. If they win, they get £2.95. So that would be 18 lots of £2.95 she would have to pay out. So that is £53.10. She makes £75 from people playing. She would pay out potentially £53.10 to winners. We want the profit, so we want the difference between those two. So we're going to do 75 subtract £53.10, which is £21.90. So we'd expect her to make £21.90 profit. 12A. A car leaves Chester at 9:27 a.m. It arrives at Taunton at 1:13 p.m. How long does the journey take? Give your answer in hours and minutes. Okay, so we're going from 9:27 and I'm starting up there because I'm going to go up in time incrementally. So first of all, I'm going to go up to the next hour. So the next hour would be 10. Remember, the minutes only go up to 60. So 60 take away 27. All right, so to get to 10 o'clock, that would be 33 minutes have passed. Okay, and then I'm aiming to get to 1. So that would be 11, 12, and 1. So that's 1, 2, 3 hours. But then we're aiming for 1:13. So 1:13. So to get from 0 to 13 minutes past is 13 minutes. So now I'm going to total that time. So I have 3 hours and I have 33 plus 13 minutes and 46 minutes. So 3 hours, 46 minutes. Part B. Bus A and Bus B both leave the station at 8 a.m. Bus A returns to the station every 30 minutes. Bus B returns to the station every 24 minutes. At what time will both buses next return to the station at the same time? So this is a lowest common multiple question. Okay, so bus A is every 30 minutes, bus B is every 24 minutes. So we're gonna write out our times tables. So we're gonna go with our 30 times tables. You've got a calculator, guys. So 30 plus 30 is 60, plus another 30 is 90, and then keep pressing equals once you've got the answer button in there. Okay, so I'm going to do some 24 minutes now. So we're going to start with 24. So 24 plus 24 is 48, plus 24 is 72. Now I'm using my answer button. I can just press equals. So that's 96, 120, 144. We're looking for the lowest common multiple. So the first one that's the same in both. So the first one we get to in both that's the same is 120. Remember, this is in minutes. So 120 minutes is when they next return to the station at the same time. Okay. We want to know what time on the clock. So from 8 a.m, 120 minutes later. So let's do 120 divided by 60. Because there are 60 minutes in an hour. So 2 hours later, guys. So we're going from 8 a.m, 1 hour is 9 a.m, 2 hours is 10 a.m. And I'm going to make it nice and clear that that's my final answer. Question 13. Zara buys 2.3 kilograms of parsnips and 3.5 kilograms of potatoes. These cost a total of £6.23. 1 kilogram of potatoes costs £1.32. What is the cost of 1 kilogram of parsnips? Okay, so if this plus this is £6.23, I'm going to work out what the cost of potatoes is because they've given me some more information about potatoes, and then that will help me work out the cost of parsnips. So Zara buys 3.5 kilograms of potatoes. Okay, so we're going to do, we know that I like these proportion tables. It just helps me organise my information. So this is kilograms and this is cost, and we're dealing with potatoes here. Okay, so 1 kilogram costs £1.32. Zara buys 3.5 kilograms, so we're scaling up. So we're going to multiply by 3.5. So £1.32 multiplied by 3.5 is £4.62. So that's her total cost for potatoes. So I'm going to take that away from the total cost of potatoes and parsnips. So £6.23 subtract £4.62 is £1.61. So now I'm going to do a little one of these tables for parsnips, guys. Okay, so this is for parsnips. So 2.3 kilograms of parsnips, so that's kilograms and cost. So 2.3 kilograms were £1.61. We want to know the cost of 1 kilogram, so we're scaling down. We're going to divide by 2.3, divide by 2.3. 0.7, so that's 0.7 pounds or 70 pence. It doesn't matter which you give it in. Question 14. Calculate the value of the sum there. Give your answer to 1 decimal place. So this is a use of a calculator question. So I'm going to copy this exactly as it is into my calculator. So everything's in a fraction, guys. So I'm going to put a fraction. And I'm going to put 2.6 multiplied by 5.7 on the top. I want to make sure it properly says accurately what it says on the exam paper, guys, okay? And then arrow down 3.4, subtract 1.8, and then I'm going to press equals. It says to give my answer correct to 1 decimal place, but the first thing I'm going to do is write down everything that my calculator tells me, because this is a 2-mark question. So this guarantees me a mark if I've put it in correctly, and then if I round wrong, I'm only going to lose the 1 accuracy mark. So we're rounding to 1 decimal place. So we're interested in these place value columns, but that 6 here makes the 2 go up by 1. So to 1 decimal place, we would have 9.3. Part B, write 68,321 to 2 significant figures. Okay, so this number 68321, 2 significant figures. First significant figure, second significant figure. So we're rounding it to the nearest 1,000. Okay, this number next to it tells us whether or not we're going to go up to the next 1,000 or stay here. It's less than 5, so we're staying here. So it's 68 1,000. These digits here need to have placeholder zeros. We can't change the highest place value of this number, but we can round it. Part C, write 6,300,000 in standard form. Okay, so standard form, we need to have a number between 1 and 10 multiplied by 10 to a power. Okay, so I want this to be 6.3 because 6.3 is a number between 1 and 10, and then I multiply it by 10 to a power. This power of 10, there's a couple of ways people do this. It's how many times you've divided this number by 10. So what you could do here is you could type this in and then divide it by 6.3. So that is 1 million. So there's 6 zeros. So we would have divided by 1 million. So we would have divided by 10 to the power of 6. The other way that people do this is if you start here, we've gone 1, 2, 3, 4, 5, 6 places to the left. So a power of 6. Question 15. The universal set contains the numbers 31, 32, 33, 34, 35, 36, 37, 38, 39 and 40. So this is our set of numbers. A is the set of odd numbers. B is a set of multiples of 3. Part A, show this information in the Venn diagram below. So these two, set A and set B, are taken from this universal set. Okay, they're not just random numbers. So A is any of these numbers that are odd numbers. So A will include 31, 33, 35, 37 and 39. B is any that are multiples of 3, so any that are in the 3 times table. So 33, 36 and 39. If you weren't sure, you could just divide each of these by 3. So 31 divided by 3 doesn't give me a whole number. 32 divided by 3 doesn't give me a whole number. 33 divided by 3 gives me a whole number. That's in the 3 times tables. We now need to sort these into the diagram, guys. So in the middle of a Venn diagram goes anything that they have the same. So 33 and 39. So 33 and 39 are going to go in the middle of the Venn diagram. In the remainder of the A circle goes anything left in this A list. So 31, 35 and 37. And then in the B circle, the remainder goes anything left in the B list, which is 36. And then on the outside here, any numbers from this set that we haven't used. So we've used 31, we've used 33, 35, 37 and 39. So that was 33, 36 and 39. So 32, 34, 38 and 40 haven't been used, so they need to go on the bottom there, like that, on the outside of the diagram, but within the rectangle. Part B. A number is selected at random from the universal set. So we are picking one number from this original set of numbers. Find the probability that the number selected is an odd number, but not a multiple of 3. Okay, so remember, odd numbers were set A. So all of our odd numbers are included in this circle, but we don't want it to be a multiple of 3, which were set B. So we're not interested in anything that's in the middle here. We're only interested in this part of the A circle because they are odd numbers and not multiples of 3. So that is 1, 2, 3. So we have 3 possibilities out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers in total. (16A). Draw an enlargement of the shape below using a scale factor of 2 and 0, 0 as the centre of enlargement. So an enlargement means we're changing the size of this shape. It's a scale factor of 2, so we're making this shape 2 times bigger. So every side of this shape becomes 2 times bigger. But the important thing here is we have a centre of enlargement here at 0, 0. So we've got to make sure we enlarge from this centre. So there's a couple of ways you can do this, guys. What people like to do is draw what I call ray lines. So from that centre of enlargement through the corner, so each vertex of the shape, for starters, so like this, here, here, and here. Because that helps us make sure we end up getting our shape in the right position on the grid. So now what we need to do is pick one of these corners. So I'm going to go with this corner here, and I'm going to plot its journey from the centre of enlargement. So it's gone 2 across and 1 up. So if I'm doing a scale factor of 2, that 2 across 1 up needs to double. So it becomes 4 across 2 up. So that tells me that this corner belongs here, and it goes on one of those ray lines. It happens to be the ray line going through that corner. So I know that that's the correct position for it to be in. Now what you can do at this point, if you want to, is do the same for each corner. So 3 across 1 up, double it becomes 6 across 2 up, okay? And mark that point and do the same for each corner. Or because you have the ray lines, we know that this point is correct as a scale factor of 2. So this side of the shape would be, instead of 2, it would double for that scale factor to be 4. 1, 2, 3, 4. Look, that takes us to the ray line that joins up with this point here. So you can conduct the enlargement that way as well if you want to. That's why people find that ray lines are useful. So then from here to here is 1. On the enlarged version it's 2 because we've got a scale factor of 2. From here to here is 1. So we would go up 2. And it's there roughly on our ray lines. And then there we have it. So our shape, I'm just going to colour it in because I used pencil and you guys might not see it very clearly. Our shape is 2 times bigger in all dimensions, and it's correctly plotted on the grid with the centre of enlargement at 0, 0. Okay, part B. 3 vertices of a parallelogram have been plotted on the grid below. Plot the 4th vertex of the parallelogram. So these are our 3 vertices. So that's the 3 corners of our parallelogram. Okay. So our parallelogram has 2 sets of equal parallel sides. So this side here will have an equal parallel side here. This side here will have an equal parallel side here. So to find out where that 4th point goes, I'm just going to plot the journey from this corner to this corner, because that should be mirrored from this corner to the 4th corner of our parallelogram. So from here we go 1, 2, 3, 4, 5, and then up 1. So from here 1, 2, 3, 4, 5, and then up 1. So we expect our 4th corner to be there. Question 17. Amy and Vance each buy a thin pizza. Amy's pizza has a radius of 3 inches. Vance's pizza has a radius of 5 inches. Amy eats 1/2 of her pizza. Vance eats 1/4 of his pizza. So this is Amy, this is Vance. These aren't drawn to scale, so we can't measure anything directly from them. This is Amy's half of pizza that she ate, and this is Vance's 1/4 of a pizza that he ate. Who eats the slice of pizza with the greatest area, Amy or Vance? You must show all your working out. So we're not just going to tick a box from what we think, guys. We've got to show working out. So we're going to figure this out mathematically, okay? So we're working with area here now. So area of a circle is pi times the radius squared, okay? So we're going to find out the area that Amy ate of her pizza, the area that Vance ate of his pizza, and then compare them and see which is the greatest. So Amy's pizza has a radius of 3 inches. So Amy is pi times 3 squared, because our radius is 3. So pi times 3 squared is 9 pi. I'm going to write it as 9 pi for now in case I need to do any calculations with it later. Now Amy only eats half of her pizza, so we only want half of that area. So 1/2 times by our answer of 9 pi, which is 9/2 pi, or as a decimal, 14.137166694. Okay, let's deal with Vance. So we're going to find the full area of Vance's pizza. So it's pi times the radius squared. His radius is 5 inches, so that's 5 squared. Pi times 5 squared is 25 pi. But he only eats 1/4 of his pizza. So I'm going to do 1/4 multiplied by that area. So 1/4 multiplied by my answer is 25 over 4 pi, but I'm going to convert it to a decimal so I can compare it. 19.634954, okay? So, who eats a slice of pizza with the greater area? Well, 19.6 is bigger than 14.13, so Vance ate the slice of pizza with the greater area. Question 18. The table below shows the mass of 90 carrots grown by a gardener. So we've got our mass ranges here, and then the number of carrots that had a mass within those ranges. Calculate an estimate for the mean mass of these carrots. So when we're estimating mean, we need to work with our midpoint, and then we use our midpoint to get some new frequency values to work with. So I'm adding in a midpoint column here. It doesn't matter whether you do it down here or up here, as long as it's nice and clear for them, guys. So the midpoint is halfway between the start and end point of these ranges. Now, if you can't spot that, add them together. So, oh, that's not very clear. There we go. So 30 plus 60 is 90, but when I half it, it tells me that my midpoint is 45. 60 plus 90, half it, 75. 90 plus 120, half it, 105. 120 plus 150, half it, 135. And then the last one, 150 plus 180, half it, 165. You might spot a pattern with these, but it's always worthwhile checking because sometimes they're not equal widths and that can catch us out. Now we have the midpoint. We're going to multiply it by our frequencies to get our new frequencies. So we're going to do 45 times 9, so that's 405. 75 times 33. 105 times 38. 135 times 8. And then 165 times 2. So we're going to add these up now to get our new frequency total, guys. So 330 plus 1080. Be really careful here because this is where you could make mistakes entering things in. So that's 8,280. That's our total frequency. To estimate the mean, we do our total frequency divided by how many we had to start off with. So we're going to divide that by 90. So divide by 90 equals 92. So an estimate for the mean mass of these carrots is 92 grams. Question 19. Jan, Frida and Peter share some money. Frida gets 3 times as much as Jan. Peter gets half as much as Frida. Part A, write down the ratio of amounts of money that they each get. Give your answer in its simplest form. So here it tells us we want it to be in the order of Jan to Frida to Peter. So they've not really given us any amounts, but they've given us some really important information. So they've said that Frida has 3 times as much as Jan, but Peter gets half as much as Frida. So because they've both, Jan and Peter have both got a relationship with Frida, so we've got Jan, Frida, Peter. I'm going to say Frida's got 1, because that's a nice number to work with. If Frida's got 1, because that's what they both have in common, she has 3 times as much as Jan, okay? So Jan must have 1 divided by 3. Peter gets half as much as Frida, so Peter gets a half. Now we don't want fractions in our ratio, guys. We want whole numbers. So what we're going to do is we're going to multiply by 3 to get rid of the third. So 1/3 multiplied by 3 is 1. 1 multiplied by 3 is 3. And a half multiplied by 3 is 3/2. You can do that on your calculator. But then I'm going to multiply by 2. I didn't give myself a lot of space. So when I multiply by 2 to get rid of this fraction, 1 multiplied by 2 is 2. 3 multiplied by 2 is 6. And 3/2 multiplied by 2 gives me 3. So my ratio in its simplest form is 2 to 6 to 3. Part B. What fraction of money does Peter get? So we need to see how many parts we have in total. So 2 plus 6 plus 3 is 11. So there are 11 parts in total. So that goes on the bottom of our fraction. We're interested in Peter. Jan, Frida, Peter. Peter gets 3 parts. So Peter has 3 out of 11 as a fraction. Question 20. Samir buys this digger and expects to use it for 1,250 hours each year. The digger will decrease in value at a yearly rate of 18% of its value at the end of the previous year. Use this information to calculate the decrease in value of Sam's digger when it's been used for 10,000 hours. Okay. So he's going to use it for 1,250 hours a year. We're aiming for 10,000 hours in total. So if we do 10,000 divided by the number of hours per year, that will tell us how many years we're working with. Okay, so that's 8 years, guys. So we're calculating the decrease over 8 years, and it's going to decrease in value at a yearly rate of 18%. Okay, so its original value was 35,950, but we're going to multiply it by a percentage, by a decimal multiplier for this 18%. So if it decreases by 18%, we want 100% take away 18%. So 100 take away 18, we want 82%, guys. I want 82% as a decimal multiplier, so I'm going to divide that by 100. So as a decimal multiplier, it's 0.82. So I'm going to multiply the original value by 0.82, but I have to raise it to the value of the 8 years that we're calculating this for. So 3,950 multiplied by 0.82 to the power of 8. So that's 7,348.686387. Okay. We, guys, are working in money. So we want 2 decimal places. So that would be £7,348.69. Now we want to calculate the decrease in value, not what its value will be, how much it's decreased. So we're going to take this from the original. So it started at 35,950, but after 8 years it was worth the amount we've just calculated. So 35,950 subtract our answer is 28,601.31. So that is the decrease in value of Samir's digger when it's being used for 10,000 hours at a rate of 18% decrease each year. Question 21. A circular wheel makes 42 complete turns each minute. Part A, how many degrees does it turn through in 1 second? Okay, so 42 turns in a minute, we're working in seconds. So that's 42 out of 60. So it's 42 turns in 60 seconds. But remember, we're dealing with a circular wheel. Angles in a circle in a full turn are 360 degrees. So we need to multiply this by 360 degrees. So I'm going to pop it in as a fraction. Hour off the fraction before I do the multiplication. So that's 252. So it turns through 252 degrees in 1 second. Okay. Part B1. State one assumption you've made in your answer to part A. So the assumption that we've made is that it turns or spins at a constant speed. Because if it slows down at any point or it speeds up at any point, then the angle, well, the number of turns in each minute is going to be less or higher, isn't it? So the assumption we've made is that the wheel spins at a constant speed. Okay. Part 2. How would your answer to part A change if this assumption was correct? Okay, so I've just said that really, haven't I? If the wheel was spinning faster, it will have completed more turns. But if the wheel was spinning slower, it will have completed less turns. So it will have gone through fewer degrees. Okay, so we're going to put here, if the wheel was spinning faster, it would complete more turns. Okay? 22a, solve 2x add 5 equals 11 plus 5x. So 2x plus 5 equals 11 plus 5x. So we're solving this equation for our unknown variable, which is x, but here we have a term with x in on both sides of the equation. So I need to eliminate one of those, and I'm going to eliminate the smallest x term. So this is a plus 5x, and this is a positive 2x. I know that that's a positive 2x because there's no negative sign in front of it, guys, okay? So positive 2x is smaller than positive 5x, so this is the one that I'm going to eliminate. So to eliminate it, I'm going to take 2x away. So when I subtract 2x from the left-hand side, it eliminates 2x, just leaves me with the 5. But I have to do the same to both sides to balance the equation. So when I subtract 2x from the right-hand side, 11 stays as it is, but 5x subtract 2x leaves me with positive 3x. Now I've got a two-step equation. Apologies, the ice cream van's just pulled up on the street. So now I've got a two-step equation. So we're solving for x, so we're aiming to isolate the x terms. So the next thing that I'm going to eliminate is the 11 from the right-hand side. That's a positive 11. I know this because there's no negative sign in front of it, guys. So to eliminate it, I need to subtract 11 because that's the opposite of adding 11. When I subtract 11 from the right-hand side, that eliminates 11 and leaves me with 3x. But I have to do that to the left-hand side. 5 subtract 11. Do this on your calculator, guys, especially if you're not comfortable with negative. So that tells us that 5 subtract 11 is negative 6. Now we've got a one-step equation. 3 multiplied by x is equal to negative 6. The inverse of multiplying by 3 is dividing by 3. 3x divided by 3 eliminates the 3 there and isolates x for me. But I have to do the same on the other side. So I have to do negative 6 divided by 3. I've got it in my calculator still. So that gives me an answer of negative 2. I don't need to write this any differently. This is going to get me the marks, guys, okay? So x is equal to negative 2. Part B. Solve 8x subtract 3x add 1 all in a bracket equals 2. Give your answer as a fraction. So this is the important part here, guys. We've got to leave our answer as a fraction because they've asked for it specifically. So we have 8x subtract 3x add 1 equals 2. So I'm going to simplify the left-hand side. Technically, what I'm doing is expanding this bracket because this is a negative 1 here. Okay, so I have 8x and then I have negative 1 multiplied by 3. So negative 1 multiplied by 3, that gives me negative 3x. Then I'm doing negative 1 multiplied by positive 1. So negative 1 multiplied by 1 is negative 1, and that equals 2. I'm now going to collect like terms, guys. So I have two x terms here, remembering that the sign in front sticks with the term that it's attached to. So I'm doing 8x subtract 3x. 8 subtract 3 is 5, so that leaves me with 5x subtract 1 is equal to 2. Now I've got a two-step equation that I'm going to solve. I need to isolate x to solve for it. So the first thing I'm going to eliminate here is that negative 1. The inverse of taking away 1 is to add 1. When I add 1 to the left-hand side, that leaves me with 5x because it cancels out the negative 1. But I have to do the same to the other side to balance the equation. 2 plus 1 equals 3. So now we have 5 multiplied by x equals 3. The inverse of multiplying by 5 is to divide by 5. So 5x divided by 5 gives me x. I've isolated the x term, but I have to do the same on the other side. So remember, 3 divided by 5. I'm going to write that as a fraction as 3 over 5. If you're not sure what it looks like, put 3 divided by 5 into your calculator and it will show you. It says to give your answer as a fraction this time, so I'm going to leave it exactly as it is. Part C. Tansy is trying to solve 1 is less than x plus 2, which is less than or equal to 5, where x is a whole number. Here's her work. So this is her working out. Ali says, you've made an error. Is Ali correct? Yes or no? Show clearly how you decide, guys, okay? So we're not just going to agree or disagree with Ali. We've got to show. So to show it, what we're going to do is we're going to solve this inequality and then see what x values we get. Okay, guys? So we have 1 is less than x add 2, which is less than or equal to 5. So what's different about this inequality, because it's a double inequality when we're solving, is rather than just having x in the middle there, we've got this plus 2. So like when we're solving normal equations, I need to isolate x, guys. So the first thing I need to do is eliminate that plus 2. So instead of adding 2, I'm going to subtract 2, because subtraction is the inverse of addition, okay? So when I subtract 2, it subtracts 2 from the middle and it gives me x. But I need to subtract 2 from both sides of this inequality, guys, to balance it. So 1 subtract 2 is -1, and I still need that less than symbol. 5 subtract 2 is 3, and I still need that less than or equal to symbol. Okay, guys? Now, what we're going to do is we're going to check our solutions. So our solutions are between -1 and 3, but we only include the value if there is a line underneath the symbol, because it means equal to. So we don't include -1, but we do then include 0, 1, 2 and 3, because 3's got that line. So x is any of those values. So when we look at this, we agree with the working out that Tansy's done, but what's different is she's included -1. Well, we don't include -1 in our solution because there's no equal to line underneath that symbol. So we've shown the working out, and we're going to put -1 should not be included. You might have spotted that straight away, but when they look like this, it's worth checking the values, and then you can spot why they've gone wrong. Part D. Represent the inequality x is greater than -2 on the number line below. So the first thing we need to do is mark at -2. So -2 is here. So I'm going to pop a circle above -2. And then we're going to draw an arrow for the full length of the number line, but for covering all values where x is greater than -2. So we're going up the number line here, guys. So our arrow is going to go in this direction because all of these values here are greater than -2. The next thing we need to check is our symbol. There's no equal to line underneath that symbol, so we leave our circle open, okay? If there was an equal to line, we would have to colour that circle in. Question 23. In an experiment, a scientist records the temperature y degrees Celsius of an object as it is heated for x seconds. The scientist thinks that the equation y equals mx plus c is a good fit for this data. The diagram shows his results on a scatter graph and his line of best fit. So a scatter graph and a line of best fit. Part A. Estimate the number of seconds for which the object has been heated when its temperature is 27 degrees Celsius. So we can estimate directly from this scientist's graph because he's drawn a line of best fit. Okay, so along the bottom here is seconds, up here is temperature. We want an estimate for 27 degrees Celsius. So we need to find where 27 is on this scale here. So be really careful when you're checking the scale. So it's going to be somewhere between 20 and 30. There are 10 little squares to cover 10 values. So each little square is worth 1. So for 27, it would be 1, 2, 3, 4, 5, 6, 7. So 27 is there. So we're going to use the line of best fit. Now I'm using a pen to make it clear on the grid for you guys, but please use a pencil in case you need to redraw anything at any point. So we're going to draw a line across to the line of best fit. And then where it meets the line of best fit, we're going to draw a line straight down to the x-axis. And then we're going to read off the seconds here from the x-axis. So we're going to check the scale because sometimes this scale could be different to this one. So from 10 to 20, that's 10 values and 10 little squares. So each little square is worth 1. So 11, 12, 13, 14, 15, 16, 17. Okay, so we estimate that it's 17 seconds that the object is heated for when its temperature is at 27 degrees Celsius. Part B. When x equals 70 seconds, the scientist measures the value of y to be 52 degrees Celsius. Use this information to decide whether the line of best fit is likely or unlikely to give reliable predictions for values of y when x is greater than 50 seconds. Likely or unlikely, explain how you decide. So we've got to use this information, and we're going to use the line of best fit, guys, okay? So we're going to go back to this graph to start off with. We can't just tick a box. We need to explain why, okay? So when x is 70, y is 52. So let's go. Well, x is 70. X doesn't go up to 70, okay, on this axis. So we can't predict from it accurately. So let's think about this, 52. Well, we can estimate 52 here, can't we? So what we're going to do, we're going to continue this line of best fit so that it carries on to the end of the grid. So we can't use the 70 seconds marker, but we can use the 52 degrees marker. So let's use that. So 52 is here. So again, I'm using pen. Please use pencil in case you need to change what you're doing. But let's roughly estimate. So at 52 degrees Celsius, we're going to read across to where we extended the line of best fit, and then we're going to read down from that line of best fit. There's enough of the axes in the scale here for us to make an estimate. So that's 52 degrees Celsius. So this line of best fit tells us that it's 51, 52, 53 seconds, okay? So that doesn't match with 70 seconds, do we? Does it? So we're going to say that it's unlikely that this line of best fit can give us reliable predictions, because what we've read off there doesn't match what the actual readings are. So what we're going to say here, we're going to give an explanation of the line of best fit predicts, what did we say? 53 seconds for 52 degrees Celsius. So we've given a comparison that the line of best fit predicts 53 when the actual values were 70. So it's unlikely to be a reliable line of best fit. Part C, the line of best fit passes through the points 0, 15 and 10, 22. Find the equation of the line of best fit. Give your answer in the form y equals mx plus c. Okay, so it passes through these points. So we're going to find our equation in the form y equals mx plus c. Remember, m is our gradient and c is our y-intercept. Okay, so we're going to start by finding our gradient m. So our gradient is the change in y divided by the change in x. You might have heard rise over run, that kind of thing, but the actual formula is dealing with the change in y and the change in x. So we have xy and xy coordinates. So the change, so from this point to this point, the change in y goes from 15 to 22. So from 15 to 22 is a change of 7, positive 7 because it's gone up. The change in x is from 0 to 10, okay? So the change in the x has gone up by 10, so that's a positive 10. So our gradient is 7 over 10, okay? So we can write y equals 7 over 10 x, but we need our plus c, we need our y-intercept. Our y-intercept, guys, happens when x is 0, so this point here. So we can either read it off the graph as 15, or we could recognise that they gave it here as a coordinate. When x is 0, y is 15. So plus 15, and that's the equation of our line of best fit. Part D, explain what the gradient of the line of best fit represents in this context, okay? So the gradient is the slope, and the slope of the line of best fit is telling us the relationship between the time that's passed and the temperature. So the time it's heated for and the temperature. So it's telling us the rate of increase in the temperature, guys, or how quickly the temperature increases with time. So how quickly the temperature increases with time. Question 24. So we've got a right-angled triangle and it tells us the diagram's not drawn to scale, so we can't measure anything directly from it. ABC is a right angle triangle. Wonderful. AB equals 4.8 centimetres and the angle BAC is 57. So AB is 4.8 is labelled for us and the angle BAC is 57. That's also labelled for us. We need to calculate the area of the triangle ABC. Okay, so to work on the area, so the area of a triangle is the base times the height, and then we divide it all by 2. Okay, so we have the height is 4.8 centimetres, but we don't have the base is BC, but we don't know what BC is. So the first thing we're going to need to do is find BC. Okay, so we're looking for this length here. Now we have a right angled triangle, we have one of the other sides and an included angle. So we're working with trigonometry here, guys. We're working with SOHCAHTOA for a right angle triangle. So the first thing we're going to do is label our sides. So opposite the right angle is the hypotenuse, opposite the other angle is the opposite, and then the side left that's next to the angle is the adjacent. Next, identify the sides that we're interested in. So we're interested in the opposite side because that's the side that we want to know the length of. We are interested in this side because we know something about it. We know that it's 4.8 centimetres. We don't know anything about the hypotenuse, so we're actually not interested in that. We are interested in the opposite and the adjacent. Okay, so when you think about SOHCAHTOA, guys, we are interested in TOA. So we're interested in this formula triangle, maybe familiar to you. So we're interested in the fact that tan is equal to the opposite over the adjacent. Okay, so we work with tan of the angle. So tan 57 is equal to the opposite side, which is x, divided by the adjacent side, which is 4.8. Now, if you're comfortable working with rearranging for algebra and solving, you can rearrange this and solve for x because we're aiming to do x equals, because that's what we're looking for. However, if you're not comfortable with algebra and solving, this is why this formula triangle comes in handy, okay? So we're looking for the opposite side. So when I cover up the opposite side, that tells me I'm doing tan multiplied by the adjacent. So I'm doing the adjacent side of 4.8 multiplied by tan of the angle that we're given. And I'm going to pop that in my calculator, guys. So 4.8 multiplied by tan 57 is 7.391351,826. Okay? This, guys, is the height of our triangle. Don't forget, we haven't finished here. We need to find the area. It's not the height, is it? Ignore me. That's the base of our triangle. That's the base of our triangle. So we need to do the base multiplied by the height, which is 4.8, and then half it. So the area of the triangle, guys, we have our base, which I've left in my calculator. I'm going to multiply it by the height. So I'm going to multiply it by 4.8. And then once I've got that value, I'm going to half it because we're dealing with a triangle. So it's 17.73924438. Doesn't tell me how to round it. So I'm just going to go that it's 17.7 centimetres squared to 1 decimal place.